Are you able to see the numbers? Online, you guys are you're not responding.
Can't see them clearly.
You can't see them. Okay. Anyways, these are just some numbers. I can shout them. These are numbers, just some numbers that you're given. We call it the data. So being given this data, you are supposed to display the data on a stem and a leaf, stem and leaf. So the whole essence of the presentation, we want to show you how we present data on these, using these different methods of data presentation. Following, right? If you look at chapter number, is it chapter number 2, lecture number 2? Lecture 2 just focuses on data. That's the whole conversation. It's around data. So to be specific, it's about how do you summarize the data using the pie chart? How do you summarize the data using the bar chart, using the histogram, using the polygons, using the stem and leaf, and using the whiskers and the box. Those are the about 7-8 methods of summarizing the data. That's what we are trying to do basically. So I'm using one question to show you how you go about, data summarizing using the same question. Is that okay? Did you get that? Or do you have a question? Any clarity to be made? There is no clarity, sir. We have head. All right. So the first thing that I can encourage you doing is rearrange these numbers in ascending order. Very necessary. Okay. You can rearrange these numbers in ascending order so that you can easily do it. You can easily come up with your stem and leaf. So rearrange these numbers. They are super jumbled. So we can rearrange the numbers. I think so. We can rearrange the numbers like starting from the first one, the smallest up to the up to the largest. We can do the rearrangement. Okay, let's do the rearrangement. Which one is the smallest? The smallest number. 24 is the smallest. Make sure you're giving us the, okay. So 24 is the smallest. We start from here. So we have 24. What else? 25. What else? 27. What else? 28. If you have two 27s, you have to make sure you include all of them. How many 28s do we have? There's just one. We are looking here at the board. There are two 28s, huh? Okay. Another 28. What else? 29. How many 29s do we have? There's just one 29. What is the next number? 30. We have a set. 30. What follows next? After 30. 32. How many 32s do you have? You have another 32. What comes next after 32? 32? 33. After 33? Or there are two 33s. What comes next? What comes next? 34. How many 34s do we have? Okay, 34, 34. What comes next? After 34. 36. We have 35. How many 36s do we have? 136. What follows after 36? Do you have 37? Yes, you have. 37. How many 37s do you have? You have 2 37. Okay, another 37. After that, what do you have? 28. 38. How many 38 do you have? Just one. Okay, after 38, what do you have? Do you have 39? You don't. You have 40. After 40, what do you have? You have 41. After 41, how many 41s do you have? Okay, after 41? 43. You don't have 42? You don't have? 43 after 43? 44 after 44? 45 after 45? 46. How many 46 do we have? Just one. How many 46 do you have? Just one. After 46, what do you have? After 46. Just have 49 as the next number, right? How many 49s do you have? Just one. And after 49, what do you have? 50. After 50, you have 54, then 61, just like that. Okay, so you have done the right thing. You have rearranged the figures in ascending order, which is now easier for you to come up with your stem and your stem and leaf. So basically, from the stem and leaf, from here, after rearranging this, you go straight to the legend. You also call it a key. It's also called the key, the legend. You give us the legend. Now, with the legend, you just choose n of the two numbers, n of these numbers, n of them. You can pick one of these. 61. So if you say 61, you write it 6 as a stem, then a leaf for 1. Then you say this means, it means what? 61, like that. This is a key, okay? We call it a legend. It's there to guide the marker, the way how these numbers are arranged. It is to communicate that these are not decimals. If these were decimals, like maybe 2.4, 2 point something, you could have written maybe 24, 2 / 4 means what? 2.4, like that. So that you can communicate to someone who is marking that, oh, these are decimals. Is that clear to everyone? Do I have a question either online or physically? Any question? No question? Yeah, even when you have 3 numbers, you know these numbers, the way how they are, the questions come, they are set strategically. They cannot bring 2 numbers and for example, here you have 24, then the others are 3 digits like that. They are never jumbled like that. There is usually consistency in the way how the numbers are brought. /1 means 24.1. Then that would mean, yeah, this one. Is that clear? Yes, sir, this is clear. So now from here, how do you form a stem and a what? And a leaf from here? I'll be forming them right from here. You're answering the question. How do you form a stem and a what? And a leaf? We are given the legend. So you just write like this, your stem and your what? Your leaf. So what is there is if you have any number that is a single digit, any number from 0 up to 1 up to 9, those are single digit numbers. It means you start with 0 here. Okay. You can start with 0. You're following, right? So that you can write 0, 7, 0, 8, 0, 5, like that. If you had the number like 6 here, 5, you could have started with 0 here so that you have been 0, 5, 0 something. Yes. 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 You got it? So what you can do is, if we are to write 0 here and not write anything, it will mean that there is no number that has got what? That is single digit. You get it, right? From 0, we have 1, we have 2, we have 3, we have 4, up to somewhere, or 5, 6. 5, 6. The last number is 60 something. So on 0, we don't have any number that is a single digit, right? We won't write anything here. Then we go on the 11. Do we have any number that has got 1 here? We don't have a number that is between 11 and 19, isn't it? You guys who are online, are you able to follow? Just a nice quick feedback.
Yes, we're following.
Okay, very good. So we go on 2. Those that have got 2, with that right, we have what? We have 24. So you write 4 here. You get it, right? We have 24. You have already written 2 here. You don't write another 2 here. So this is the 24, then 25, 27, 28, 28, right? 20 what? 29, like that. You end here. There are 2 28 here. You gave me 2 28. Ma? Why did we have to select from 0 up to 6? Really, this, like, it doesn't really have a lot of meaning, as they say. But there is some meaning, because in the long run, you should be able to explain how this data is distributed. Is it right skewed? Is it left skewed, or what on what? That's why I'm teaching you to arrange the numbers like this. I'll show you what we are communicating. I'll show you. You should be able to graph these later on. Yeah, if you write it, 24 here, then you write 4 again. No, this will mean that this is a maybe 24.4. It will have some other meaning. It will be 40. Okay, I've gotten that. We go to 30. In the range of 30, we have 30, 0. After 30, we have 32, 32, 33, 33, 34, 34, 36, 7, 8, like that. All right? 8. Then we go to what? To 40. We have 140. We have 40, then 40. We have 41, then 40 what? 43, 44, 45, 46, 49, like that. Then you go back to which one? To 50. How many do you have? Just have 50, right? 50 and the 20, 64, like that. Then on 60, just have 60 what? 61, like this. Now look at the way how this data is distributed. Check how this data is distributed. If you are to graph this, it will be like this. What kind of distribution is this? Is this symmetric or right skewed or left skewed? Oh, I'm not confusing you. The way how you write this number communicates where you have a lot of numbers, okay? And usually where the line where you have a lot of numbers, that's where your mean will lie most of the time. Not most, always. If you have to calculate your mean, you find that we have a lot of numbers in the range of what? Of 30, right? So if you calculate your mean, will be somewhere around in the range of 30, like that. You get it, right? Then if you observe the way how this data is distributed, We have more numbers to the right of, this is the right. We have more numbers after 30, right? That's on the right side. We have more numbers after 30 as compared to the numbers after before 30. So which means that this data is right what? Right is skewed. You get it, right? Right is skewed, meaning it is skewed to the right. Like the data is skewed to the right. Most of the data lies to the right side of the mean, like this center, like you get the point? Yeah, I know this communication will be more clear when you do a histogram again. You also talk about how the data is distributed. So if this data, like if you had a lot of figures this side, you could have said this data is left what? Left is skewed or negatively skewed. So positively skewed and right is skewed, negatively skewed or left is skewed is the same thing, okay? Then positively skewed or right skewed, it means the same thing. Is that clear online? Do you have a question? When they're still responding, you guys, are you clear? Are you fine with us? Okay. Here is an addendum to the question. My addendum is, if you are asked again, before we come to the mean, can you calculate the range from here? Are you able to calculate the range? So basically, the range is there. You know, if you are following the things I'm talking about are there in lecture 2. The range is basically the highest number minus the what? The lowest score. The highest score minus the lowest score. So the highest score, it's just picking. It's here. It's 61 minus the lowest score shall be what? Shall be 24. So what is the range? 61 minus 24. Like the maximum score minus the lowest score is 27, right? 37. 37 like this. Okay. Found? Yeah. So this is called your what? Your range, like range. Is that clear? I'm using one question to communicate everything. Did you get that? Yeah, because sometimes this is how the questions are brought. You've seen in an exam whereby you are asked to do a stem and leaf. From the stem and leaf again, other questions now start what? Start coming. You should be able to play around that. Yes, ma'am. The first quarter. I'll come to the quarters. Let me come. Let me leave the quarters in the meantime. The range is basically the highest score minus lowest score. You got it? Okay, let's quickly move to the mode. You guys who are online, are you able to follow? Maybe you are disconnected. It's good that you confirm. We can keep on talking and you're not hearing.
We're following.
Oh, okay. Now the other question is the mode. It's not here. Yeah, if you have followed the past papers that I'll send you, they have such questions. So I'm just communicating things that I've seen so far. You can be asked to find the what? The mode, like here, the mode. How do you find the mode? The mode is basically the most frequent score, okay? When you go to lecture 2, you find that the mode is defined as what? The most frequent score. There is that value which keeps on appearing or that appears many times. That one is called a what? The mode. Okay. So in this respect, which number appears many times than the foreign? This one should never be read as 4. It's 24. Like that. So which number appears more times than the foreign? Yes, madam. Yes. Okay. Okay. Many times. Thank you. So how many numbers appear more times? There is 28, 1, 2, 20, 32, 33, 3, 34. How many? 1, 2, 3, 4, 5. 5, right? Yes. So it means that this data has got how many modes? It has got 5. You select all of them. You're following, right? It is possible. You have never heard of this now. You are hearing it for the first time. It's true. Sometimes you can have maybe, most of the time, let me start from when you have only one mode, right? The data set is said to be unimodal. Okay, unimodal. Unimodal. If the data set is unimodal, it simply means it just has only one mode. You're following, right? Then if you have got 2 modes, the data set is said to be what? Bimodal. Okay, bimodal, because bi means 2. It has got 2 modes. Then if it has got 3 modes, it's said to be what? Trimodal. The data set is said to be trimodal, meaning it has got 3 modes. Should the data set have modes that are more than 3, it is said to have polymode. Poly means many. Polymodal, okay? Polymodal, the data set is polymodal, meaning it has got the modes that are more than 3. Is that clear? You are supposed to list all of them. Yeah, you are supposed to list 28, 22, 20, not 22, 28, 32, 33, 34, and 37. Is that clear? I hope this is clear, right? Okay. If this is clear, we can move on to something else different. Yes.
How do they do that? They ask them what exactly do they do?
Okay, now I'll show you under the chi-square. Not the whiskers and box. That's where you detect the outliers. We'll show you. Don't come. Take it easy. The size there to make things easy. So from here, you have another question. The question is, what is the median from here? Right? What is the median? Hi, I can come in. Just trying to go through some question under stem and leaf, 2020 paper. So we had this data, right? We had this data, we have this data. From this data, we are supposed to extract a stem and what? And leaf. We have already extracted a stem and leaf. So we are continuing by answering the question such as, what is the mean from here? That's where we are now. What is the mean? How do we find the mean? Okay. So if you're asked to find the mean, this is how you find the mean. Oh, not the mean. Let's start from the median. Sorry. Of course, we'll be asked to find the mean. We have done the mode. We have done the range. Let's do the what? The median. How do you find the median from the stem and leaf? So you're gonna cancel this one and this one, and this one, and that one, right? This one and this one, right? This one and that one, this one and this one, right? This one and this one, and the other one, this one and this one, and the 6, right? You're following, right? Then this 4 and this 0, right? This 4 and the 2, this 2 and the what? And the 3. Then you have 33 as the median. Did you get it? No, there is there is nothing else. But, you know, the median is just the number that is in the middle. For this data is it's ungrouped data. So you just do that for ungrouped data. We'll show you how we find the median when you're dealing with a grouped data. Okay, this data is not grouped. You got it? You got that? Okay. Mr. Chirinda, are we together, sir? The 27.
Yes, what to do?
The number that is in the middle. Perfect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27. Which side? The ones that we were grouping. Unless we missed one number. Unless. So which number might have been missed here? You can identify.
No, I think we just put the numbers correct, but we have made a mistake because these numbers are supposed to be fixed.
So that's why I'm saying let's check which numbers have been missed. There is 24 here, there is 25, there is 127, 228, 129, 130, 232, 233, 234, 136, 237, 138, 140, 141, right? 43, 44, 45, 46, 49, 50, 54, and 61. Which number might have been?
Because when I was watching the numbers, they are
Okay.
they are
Okay. Identify the number which is not there, kind. Yeah, you're right. I'm not refusing what they are saying. I'm saying, can you identify the number that is not there? Colleagues, identify the number that is not there. Of 245. There's a 45 here. The original question says, 45. Here's the original question at the board. How many 45s do you have? There's just one 45. Yes. Ready. Divide by 2. So you add them and divide by 2 if there are two numbers that are in the middle. Is that clear? If it is 36 point what? 0.5. So basically that is your what? That is your what? The median. As if as it is. So from there now, you can find the mean. Finding the mean will be easier. What is the mean? The mean is basically given as x bar equal to the summation of x divided by n, which means that you are basically summing up everything here, like all these numbers, adding them. You will not add them as 4, no, you say 24, right? So 24 plus 25 plus 27 plus that one plus that one plus that one, you get it, right? You are adding all the numbers, then you divide by what? By 30, since they are 30. And whatever you get is the mean. Did you get that one? Did you get it? Yes. Okay. Any question? Is there any question? There is no question. Before I go straight to let me skip a bit on how to extract the standard deviation and the coefficient of variation. So I move quickly to the frequency table distribution. How do you display this data on a frequency table? Oh, it's interesting. Let's go. Let's see how we display this data on a frequency table. Now, the first thing that you need to do, the first thing that you have to do is to, who is this one? Hi, come in, madam. So I was thinking, these strangers, the young students, you can just sit in the background. We were still doing a little bit of math. You take math as well. Yes. So we're just doing some paper in 2020. Yeah, it had these questions. So they're the ones that we're trying to do. Yeah. So how do you present, if you're given a stem and leaf like this, right? Then the question is, can you extract the frequency table distribution from a stem and leaf? How can you extract a frequency table distribution from a stem and leaf? This is what you do. But first, you find the range. The range is found by saying the highest number minus the lowest what? The lowest score, right? So we found that it is set what? 7. You're following, right? This set 7, what you do, you will divide it by the number of the bars that you will square root the range. Okay, let me speak like this so that it's me clearly. I'm sounding like someone who's mixed up. What I'm saying is the first thing that you do, okay, in the normal order of the way of doing things, you count how many they are. How many are they? They are 30, right? Then you do the square root of the 30, right? That will give us the number of what? The number of the bars that you need for a frequency table distribution on the number of classes. You get that the frequency table distribution has classes, right? What you're trying to do is to group this data. It's a group the way how it is. You need to group it. You want to group it. So how do you find the number of classes? How many classes will be there? Or how many groups? You say the square root of this. How many? What's the square root of 5.47 something, which we can easily round off to what? To 5, right? Are you following, right? We shall have 5 classes. Okay? Yes, sir, we'll have 5 classes. Now that we have 5 classes, this number of classes that we get, we'll divide it into the range. So you say the range is 7 divided by this should give us the class width, how big the class will be. We have said we need how many classes? We need 5 classes, but how big? Should the class only contain 3 scores or 4 scores or 7 scores? So the question on how big the class will be answered by dividing the range divided by what? By the number of the bars or the number of classes that you are finding. What did you find? 7.5, which is approximately 8, right? 7.4. Okay, which is 7. So approximately our classes would be of size what? Size 7. The class width, that is the class width, how big the class is supposed to be. So when you're creating the classes, you start with the first, the lowest number here. Are you able to follow? The lowest number here, you say 24 plus 7 here. This, are you able to follow? Yes, 24 plus 7 is what? So your class will be 24 to what? 24 plus 7. You'll be adding 30 what? 31. Then from 31 to, you add 17. It will be 38, right? Then from 38 plus 7, what do you get? 40 what? 45. Then from 45 to, you're grouping the data. This is what you're doing now. 45 plus 7 is what? 52. 5 is 2. And then from 5 2 plus 7, 50 what? 50, 50, 59. Then all what we are going to do, since we still have some numbers like 61, which is not captured in the range, we'll do the last class, which will be 59 plus 10, add the 7 to this. 60 what? 66. 1, 2, 3, 4, 5, 6 classes. Why are the classes 6 instead of having 5 classes? It's because you are rounding off. You get it, right? You're rounding off as well as round off, like you were removing some numbers. So some numbers are not being captured in the 5 classes. The 5 classes only end here. But why creating another class is because you need to capture and incorporate all the numbers. Is that okay? Yes. Then from here, what you need to do, you have created the class, right? This is the class interval. Then you need the frequency. Okay. You need the what? The frequency. How do you create the frequency? Follow. The frequency, now you ask yourself, how many numbers are between 24 and 31? Can you count them? Like they are countable, they are here already. All of them between 24 and 31. So we have 1, 2, 3, 4, 5, 6, 7. Right? Yes. So your frequency is what? Yeah? Is 7. Is this difficult? Very difficult? Very easy, right? Yeah, you already know it actually. Then from 31 to 38, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and what? And 12, right? So your frequency of what? Will be 12. Yes, madam. Yes, madam. Yes, frequent. How frequent? Yes. The individual score appears. That's what we are answering. You got it? Yeah, it's not that when you write it at once, then you, like you know how you do it, it's in sets, right? It's in sets. If you list the number once, we're talking about frequent. How frequent? You get it, right? Yeah. So you go to which one? Set what? 38 to 45. 38 to 45. 1, 2, 3, 4, 5. Plus 45. Then. There are 5, right? Then after 45 up to 52. 1, 2, 3, 4. They just what? See? They just 4. Right? And you go between 52 and 59. Just have only one what? One figure, right? Are you able to follow? Yeah, there is just only one figure here. The frequency is 1. Then from 59 to 66, 59 to 66, there is only 61, right? So you have only one as what? as a frequency. Then what is the total frequency? You sum up everything. I'm showing you something so that your lecture 2 becomes familiar to you, very familiar. Yes. What is the sum of all these things? It's what? 30. The total frequency is what? Is 30. Are you able to follow? Then the other question that you should understand is now, how do you come up with the relative frequency? This one is called the frequency. But you also have what is called the relative what? The relative frequency. How do we come up with the relative frequency? Let me just write it as RF. Frequency F, RF, relative frequency. Basically, in the relative frequency, you divide each individual frequency divided by the total what? By the total frequency. These are the same things that are there in chapter 2. It's only that this is the other version. You get it, right? Yes. So you say 7 divided by 30, the total frequency. What is the relative frequency? Yes. 0.233. 23. What about the relative frequency here? 12 divided by 30. 0.4. What about 5 divided by 30? 0. What? 0.57. 17. What about 4 divided by 30? I'm sure you're connecting now. Are you able to connect? Yeah, you should be able to connect. So you can observe that from a stem and leaf, you can even come to what? The frequency table distribution. From here, you can even extract the bar chart, the histogram, the polygons, everything. That's from a stem and leaf. You get it? Yeah. What do you get? 0.13. Then 1 divided by 30. 0.03. 0.03, and this is 1. 30 divided by 30. Have you observed on how you've known how you come up with the relative frequency? Have you known how to come up with the relative frequency? That's my question. Mr. Chirinda, sir, have you known how we come up with the relative frequency? And the friend?
Yes, yes, I have.
Okay. Then the other thing that I Okay, like I want to show you how you come up with the bar chart from this very data that you have. How do you come up with the bar chart? The bar chart is always plotted against the frequency, okay? Against the frequency. So we start with the frequency that we have. Our frequency, we can divide our frequency into tools, right? Even the tools, right? It do tools up to somewhere 12. That will be, okay, even the tools. So in 0, 2, 4, 6, 8, 10, 12, 14, right? Are you able to follow? Then on the horizontal axis, you put the classes. You're getting lost? The bar, yes. You put the what? The classes. Now, the way how you put the classes, you put spaces in between. So you say there's a class from 24 to what? To 31. You have a class from 31 to 38, from 38 to 45, from 45 to what? To 52, 52, from 52 to what? To 59, and from 59 to what? To 66, right? To 66, like this. So these are spaces, like the classes. So what you're doing is this. When you're coming up with the bar chart, I'm talking about the bar chart first, you are plotting it against what? Against the frequency. So how you do it, you come to the class, ask yourself, what is the frequency in this class? 24 and 31. This class is 7, right? So you go where there is 7. 7 should be in between here, between 6 and 8. So it's somewhere here. You write like this. Bam, bar like this. You put like that. Okay? This is the bar, like the first bar. Yeah, 7. Okay, you're plotting against the frequency. The frequency is 7. The next class is 31 to 38. The frequency is 12. So it's a line up to 12 here, like that. Just like that. Then from 38 to what's the frequency? 5, right? 38 to 45 is 5. 5 should be between 4 and 6. Somewhere here. So it will be like this. Then the next one is what? The rest of them, the next one is 4, right? 45 to 52. 45 to 52, the frequency is 4. So just somewhere here where there is 4. And the rest is 1, 1. Right? Yes. It's 1, 1. Here up to 1 here. And even the next one up to 1. But if you observe, you find that there are spaces. So basically, this is how we come up with what? The bar chart from the stem and leaf. See where we started from? From a stem and leaf, you can even come up with the bar chart. You got it? Hello? Any question? There is no questions. Like I'm concluding, I know you're tired. Just give me less than 5 minutes. I'll be done. Everything. I'll be done communicating almost everything. Now that we are done with the bar chart, how do you come up with a histogram now from this very data? With a histogram, the only difference, by the way, between a histogram and a bar chart is that the histogram, the data is joined like that. So there are no these spaces, histogram. On the bar chart, the data is spaced like that. So what you do is this. This is how you are going to do it. You always, even for the histogram, is plotted against the frequency still. So the frequency remains the same on the vertical axis. But the way how you're going to do your classes, this is how you do the classes. Your classes will be joined from 24 to 31, and from 31 to 38, from 38 to 45, from 45 to what? To 52, from 52 to 59, from 59 to 6 to what? 6. Have you seen the way how we write? You're following? a histogram now. So again, you start plotting again the frequency. So what is the frequency between 24 and 31? It's 7. So you plot like this, up to here where there is 7, like that, like this. Then the next frequency is 12, right? From 31 to 38. So you just increase this up to 12 here. And then you come to the right, you draw like that. The next frequency is 5, right? Yes, you come here where there is 5. And the next frequency is 4. 4 is here, straight. 4 is here, up to here. From 4, number 1, 1. Between 0 and 2, we have 1. So it will come here straight here, and from there up to there. This one is your what? Your histogram. You got it? Very easy, right? Very easy, very straightforward. So this is your histogram. And with a histogram, you can easily draw a line if you are interested. Like from 0 here, there is a straight line here. The data is like on top. Oh, sorry, it goes up to the last one. This explains how this data is distributed. It has got the longer tail on the what? On the right side. So you say the data is right skewed. Okay. So this data is what? It's right skewed, meaning you have a lot of figures on the right side of the what? Of the mean. You got it? And it shows that the mean is where is the center? The highest frequency is between 31 and 37. This is where even the median is. And we calculated already the median. We found that it was 34, right? It's between this one. Even the frequency, the highest frequency is where? It's here. Have you followed that? We're just talking about the same thing, basically. So when you check, you find that there is a longer tail on the right side. You say that this data is what? It's right skewed or is positively skewed. Meaning most of the data set lies on the right side. It lies on the right side of the what? Of the mean. You get it? Yeah. That's the measure of skewness that we heard about. I'm sure the lecturer talked about the measure of skewness. That's how you come up with it. This is how you define, you analyze from that. Is that okay? Yes. I've talked about the bar chart. I've talked about the histogram. I will not talk about the pie chart. It's basically very straightforward as well. Just do the circle. With the pie chart, you do the circle. Then these classes, you put a class, for example, a legend. Take a box here. Maybe you put a green color in here. You're following, right? Then you mean that the highest class is which one? Between 31 and 38, right? Then it means that the part which will have a bigger side is this one. You get it? You break down your pie chart like that. 1, 2, 3, 4, 5. Then how many? There are 6, right? There are 6. Like this. Then the one that is bigger, the one that will be bigger, like this one, maybe you paint it green, right? Then when you put a key, you put a key to this class. You get it, right? And in this class, you label it green. So that you know that, oh, this biggest part is for this class between 31 and what? And 38. That's basically a pie chart. If you have enough space, you can even label the classes 31 to 28. Like that on these parts of the pie chart. Really, you won't suffer. The last thing is the polygon that I'm talking about in 1 minute. You already know it. Like the polygon, basically, it is the plotted, like you're plotting the frequency against the midpoint of these classes. You get it, right? The midpoints of these classes, you know how to get the midpoint, right? Like you add this lowest score plus the highest score divided by 2. Do you remember how you get the midpoint? You know how you get the midpoint? Like it's some number between this one and that one divided by 2. It's somewhere here, right? Then you plot a point here in the middle, like in the middle of the class. Middle of this class again is the frequency to be somewhere here for this one. Then for this one, it will be again is here. This one, it will be here. This one here and that. Then you just join these lines like this. How does it move? It moves like that. This is a polygon that I've just drawn inside. It's a polygon. Any questions? There is no question, sir. We have heard. Do I have any questions? Sorry? Yes, there's a question. Like you should put the figures here. Yes, you put the class the way how it is. As if you want to do a histogram. Imagine these classes are not there. All these bars are not there. Yes. Just putting the midpoint. Yes. So this is how you will do your polygon. No of these bars will not be there. This is your polygon, right? 24 plus 31 divided by 2, it will be some mid number here. Again, it's the frequency. Then again, this mid number here, again, it's the frequency. The frequency of this class is short. Then 27 point is somewhere here. Again, it's the frequency 7. Just like that. Difficult? Those guys who are online, are you able to follow? Are you clear? Are you fine?
Yes, it's clear.
Okay, do you have any questions, sir?
No.
Okay, very good. We are happy to hear that you don't have any query and you are okay with this. So, I have communicated everything that you wanted me to talk about. What didn't you? Only apart from the whiskers and box, right? And the percentiles. Those I'll talk about them. Yes. I think you did those things in high school, guys. Coming up with standard. Okay, I'll talk about them during the week. Right? Yes, I'll talk about a whiskers and box. Somebody asked you the question. I'll do a question and a recording on whiskers and box. What else? The how to do percentile, of course, is one thing. Okay? You can't come up with a whiskers and box without a percentile. Without percentiles. I'll talk about them. And what else? Sorry? A chi-square table. Okay. Those are the only things that you want me to talk about. In lecture two, what do you want me to talk about? The outliers. Yeah, they are under whiskers and box. I'll talk about them when. Yes, I'll talk about them when I will be presenting on the whiskers and box. Okay. Let's have a 2 minutes commercial break. Then we do the right thing. Don't get tired of learning, like guys. We are not off school. A patient. Okay. Okay, you're not still anywhere. What about Leon? Okay. All right. Okay. Let's do this nice thing. I am expected of talking about the final account. The final account. with you, but it is necessary, I think, for me to talk about the format of the final account for the sole proprietor before I can give you the entire question to do, like we do together. But first, you know, these things of accounting, it's about to getting the template, then everything follows suit once you have the format. So I want us to talk about what is the format actually for the final account, and yes, the final account. Is that clear? Yes. It's time for financial accounting, those who are not aware. Yes. Okay, listen now. Yeah. It's not a very long class. It's just a very short but very interesting class. Yeah, very short but very interesting. One thing that you need to understand is I'm giving you the background behind the final account. Okay. The businesses grow. You're following, right? I'm introducing the topic. The businesses grow. Once you start a business, the business will start growing and growing to an extent whereby you will start now incorporating other people. I didn't stop recording. So in this recording, accounting will